Hi everyone, my name is MC and today I'll be talking about factors that influence a home's value. So just an outline, we'll talk about the context, problem to solve, the Kaggle competition that has started all of this, which is the house pricing prediction, and as part of the solution, we explore the data through Python, and last, and the most important thing, insights. Okay, so imagine that you're about to buy your very first house. What's the first thing that comes into your mind as the most important factor that you consider? So is it the size, design, year built, or number of rooms, or just like me, location? And it's accessibility to groceries, restaurants, hospitals, etc. So the general question is what makes a house expensive? Each person might have their own preferences, but here we try to look at the data and understand what factors affect the property value. It's a bit of a spoiler, but I want you to understand the flow of the talk. We're in the first phase, and we're aware now that we have a question in mind and a problem to solve. And to answer the question, we need the data to back up our conclusions and insights. So, there's an ongoing Kaggle competition about house prices advanced regression techniques. The main goal of the competition is to be able to build an ML model that precisely predicts property value. As every ML engineer's starting point, we first have to get a good dataset. Then we explore the dataset before feeding it to the model. So the Kaggle competition provided a dataset called Ames Housing Dataset, which contains real estate information from Iowa and has 79 exploratory variables and thousands of entries. The main goal is to extract information from these dataset. We're using Pedro Marcelino's 5-step as well. Okay, so we jump right into the second phase. This part is the meat of the talk. Now we'll discuss all the processes I've done to massage a large amount of data. And it's crucial to feed good training dataset for your model. This method largely affects the performance of your model. So we go through each column of the dataset and understand the bearing of these columns. When it comes to data analysis, there are a lot of tools available, and one familiar tool for everyone is Excel. So here I made an Excel sheet that tries to understand per column. The orange cells are the columns from the dataset, while the red cells were set by me. So the variables are the names of the columns. The type is just a classification between numerical and categorical, and you have to be careful here because you might interchange them with some variables. For example, year. It is numerical, but when you analyze it properly, it is categorical. I mean, by appearance, it is numerical. So for this segment, it's a classification between building, location, and space. This column helps you visualize every variable. The expectation is quite subjective. Think about the variable that can influence the property value. Maybe you can ask yourself, do we think about this variable when we are buying a house? Here, we try to develop 6 cents. And we have to take note also that this process can be a bit of bias, and also priorities are going to be different when you're in a colder place, like how a fireplace will matter in Finland but not here in the Philippines. So next is the conclusion. The last column is just kind of a correction of our expectation. So it's like thinking twice just to be sure. So after that very long tedious process, I've concluded that there are 4 variables that play an important role in this problem. So we have lot area, the overall quality, overall condition, and the year build. So after this step, we now proceed to get to know more about sale price. So sale price is actually the star of our quest. So in order to predict sale price, you have to understand its behavior. Using Python, I obtained the descriptive statistics of sale price. So luckily, I found out that there's an actual minimum and it's not 0. So this data point won't ruin the data process. And as you can see, all of the entries have actual prices. Next, I obtained the histogram of sale price to understand its behavior. You can notice that entries ranges from 100,000 to 300,000. And from this histogram as well, I concluded 3 things. So it does not follow normal distribution. It shows positive skewness and it shows pickedness. And later, we'll see the weight of these insights, and next thing to do is to try to observe its relationship with some variables. So here I'm showing you two plots. These relationships are a bit obvious, but as data scientists, we plot to establish it as a fact. Most of its relationship with the variables are directly proportional. I've shown there two variables which are overall quality and ground living area. So both of them show a positive relationship, which means higher quality, higher price, and a bigger living area, also higher price. So it's also good to visualize its relationships so you know its interaction with other variables. Okay. So now we need to go deeper. The first two methods were a bit subjective and biased. So as data scientists, we want to generate data-driven conclusions. So now let's try to proceed with making a more objective analysis. Okay, so the best way to show the relations between sets of variables is a heat map of correlation matrix. These allows you to see relationships with the highest correlation, and as you can observe, I enclosed here two blue boxes for certain variables with lighter shade. So the first one refers to total basement square feet and the first floor square feet variables. The other one refers to garage X variables. So these boxes are an indication of the relationship's significance, and if you think about it, these boxes state the obvious because bigger garage areas, more garage cars capacity. And a big basement area gives almost the same measurement above ground. So therefore, we can conclude multicollinearity from these variables, and this detection of multicollinearity is one of the many advantages of using a heat map. So now let's try to focus to sale price correlations. And the best way to do this is to zoom the heat map and make it specific. Okay, so here we observe that there is a strong relationship between garage cars, garage areas, and total rooms above ground and ground living area. So also, we see that the variables that affect the sale price the most are overall quality and ground living area, as you can see with the lighter shades. So before we had a subjective conclusion of 4 variables affecting it, and now we confirm that the data telling us that there are 2 variables. And now that we understand more of its behavior, let's try to clean the dataset as well. So here, aside from just the basic cleaning of dataset, this step is also essential because of its capability to reduce the sample size. And reducing the sample size can help in preserving computational resources as well. And another thing is when handling the incompleteness, we want to know if the missing data is just random or it does have a pattern. But more importantly, we want to ensure that the incomplete data is not biased and hiding unessential information. So with that, I obtained columns which have incomplete data. So here, you can see that there are 19 columns. I just followed Marcelino's rule of deleting the corresponding variable when more than 15% of the data is missing. So therefore, I deleted the 6 columns, the pool, miscellaneous, fence, fireplace, lot frontage, etc. So judging from the input of these columns as well, the variables seem to be not important. These aspects are strong candidates for being an outlier. So analyzing the next variables, which is the garage X variables, the mason veneer variables, and the basement variables, the same percentages might imply the same set of observation. So deleting these variables will not matter. And the last one is the electrical. So I can simply delete the one entry with missing data but keep the column. We now look at the 2 biggest factors of sale price, which is the overall quality and ground living area. There are no outliers for overall quality, so as you can see here, I'm focusing with the ground living area here, which has 2 outliers enclosed in a red box. We simply delete these 2 entries and we avoid outliers for our model to have a better training ground. So you have a large amount of data, so dropping these 2 won't hurt. Next step is let's try to massage the data. This part is mainly for checking if the data meets the assumptions of multivariate techniques. Let's talk about the normality of data. We expect and hope a normal distribution theoretically. So transforming the data into normal distribution is essential as several statistics tests rely on it. And the way to solve the problem here is to tweak the data And according to a statistic book by Hare et al., we apply a log transformation since we're seeing a positive skewness. And applying that, now we have a data with normal distribution. And you can do this especially with the two most important factors, overall quality and ground living area. Okay, so now that we're almost done, so if you do need a break, you can pause this video a while, drink some water, absorb all the analysis we've done, but if not, we can move forward. So the last part is just the insights. It's basically summarizing all the extracted information so you can take note of these and apply it when building your own machine learning model. So the biggest takeaway from this exercise is the importance of generating data-driven conclusions from data. Number one, we analyzed sale price alone and we found out that the overall quality and the ground living area were the biggest indicators. So if you think about it, this is a bit against the norm. We think that location is the biggest factor of property value, but here the data says otherwise. Observing the heat map as well, there are variables that do not show positive correlation like an enclosed porch, kitchen above ground, overall condition, year built. So it does not necessarily mean that these variables are negatively correlated, but more on it does not show the strongest relationship with sale price. And I guess it's a good insight from the data since our first observation thinks overall condition and year built are factors, if you remember the past slides. Okay, so looking at the histogram before, we observe a heavy tail distribution. It could be possibly a Pareto principle where 80% of all houses only account for the 20% of the real estate market, though I'm not so sure, and definitely there's a need of more analysis and modeling to do, but this principle can help you understand sale price more and adjust how you write your algorithm based on it. There's so much more information we got each process, but these are the major insights we extracted from exploring the data. So, the quest is not over yet. This is just the starting point of the challenge. For me, it's the most tedious but a very essential part of machine learning, and a lot of data scientists tend to overlook this process and just jump too soon into the water. And you don't want to do that because what quality goes into your model goes out as well. It's time to predict the house price, and I'm going to leave that to you with your machine learning skills, and you can join the Kaggle competition as well. So these are my references. If you want to know more about my Kaggle notebook or delve into Marcelino's methodology, you can check the links provided on these slides. I also want to acknowledge that the whole process was based on Marcelino's EDA. So big thanks to him for writing a structured and concise data analysis guide for beginners like me. And as well as thank you also to Arden for reviewing my slides. Yep, I guess that's it. Thank you for watching this video and I hope you learned a lot. If you have any questions, feedback, suggestions, feel free to email me. Thank you. Bye.